Hello everyone, welcome to Zahid's Data Mining channel once again. Today I will demonstrate briefly, very quickly, how to build a classifier, a machine learning model from a dataset, and then how to apply that classifier on a testing dataset um, and predict the class values. And I will also, of course, discuss what is a training dataset, what is a testing dataset, and how do we build models. Now, first, I will show you that I have here, for example, a dataset known by the name diabetes.arff. Arf.arff is the format used by Weka, which is a very commonly used data mining software tool. So let us open this diabetes.arff file in a text editor and see what the file looks like. As you know, that ARF file format has some header information about the variables. There are quite a few variables, I think 8 or 9 variables. And finally, the last variable is the class variable, which has two possible values, tested positive and tested negative. So this is possibly on patients information, this data set on various patients information. First one is their preg value, class value. This is their preg value, this is their class value, etc. And finally, this is their class value, which is the diagnosis of the patient, whether the patient is tested positive for diabetes or tested negative for diabetes. So this is the entire data set that you can actually download from UCI Machine Learning repository. And also when you install Weka, it comes with that installation in the data folder within the Weka installation. Wherever you install Weka, so go to that folder, you will have a data folder and you will have this data set there. Now, from this data set, I have created two data sets. One is training data set, and if we open the training data set again in a text editor, and testing data set, I have a testing data set as well. Open that testing data set in a text editor, then we will be able to see that, let me explain. So what I have basically done here for this demonstration purpose, from this entire data set, I have chosen first 4 or 5, 1, 2, 3, 4, 5, first 5 records as my testing record. 1, 2, 3, 4, 5. These 5 records from the original data set. I have taken these records off from the original data set and put them in this testing data set, where in the original data set, I knew their actual class values. But when I put them in the testing data set, then I have removed the class values by question mark. That means the class values are unknown. So by copying these records into a new data set, I have created the testing data set. And by removing these records from this original data set, I have created the training data set. See, the training data set does not have these 5 records. It starts from these records, okay, for which the preg value is 5. So that is that record. So the idea here is a user or a data miner generally will have access to a training data set only. So they will not have access to the entire data set, okay? They will have, this is their entire data set, the training data set. And then based on the training data set, and again, you know, the training data set is already labeled, right? It has negative and positive class values. So it has all patient information and whether the patient was tested negative or tested positive. So for every patient, it has all patient information and then the test result as well, diagnosis as well. So this is what a data miner will have access to. Now, from this data set, the data miner can build actually a machine learning model. And then when he gets new records coming to his hospital or to his diagnostic center, and then he can get all other information through pathological tests or through medical examination, and then he just does not know the class value. Now, class value can be diagnosed by a doctor, of course, but here the idea is by knowing other information, can machine learning models predict the class values? And this is just an example here. You can think of a possible example in a banking environment or in a banking context, when a bank knows their previous customers and their various information about those customers like age, profession, background, education, income, etc., loan amount. And then they also know whether that customer returned that loan, repaid that loan or not, so good customer or bad customer. And by knowing all these previous information of thousands of customers and their result, whether they were good customers or bad customers, they can then build a classification model and apply the model for future customers when they know about their age, their educational background, their income, etc. Then they can predict whether this customer will be a good customer or bad customer. And based on that, they may, this information, this prediction can influence their final decision whether to give a loan, approve a loan application or not, something like that. So this is just an example. So you now know what is the purpose of a training data set and what is the purpose of a testing data set. Now, all we will need is to use this training data set first to build a model. So how we do it, we can here in this example use Weka. It's a freely available software tool. You can download it and then you can use it. So when you get Weka GUI Chooser, you need to open the Explorer window in Weka, and then you need to open the data set. Okay. So in order to open the data set, I need to click on the open file, and then I can browse there, browse through my file system. And then remember I had a diabetes training.arff file, so that I just showed. So I will open that training file. So this is that training file, and you know that Weka has so many different things that for visualization purpose, you can see the attribute values, their mean, median, etc., and you can see their relation with the class values. So there are two class values. One is tested negative. There are 498 of those cases and some tested positives. And also you can visualize all to see that, okay, so for all attributes, how they are related with the class attribute. So you can get some information there. But now, for building a classifier, you can go to the Classify tab and you can choose a classifier. In this case, I'm choosing J48 classifier, a simple J48 classifier with, say, 50 records per leaf, just to make the classifier as simple as a simple classifier. And then I can use the entire training data set as the training data set, the data set that I've uploaded, which is diabetes training.arff file. That was the training data set, right? So as I showed before, that was the training data set without those first 5 records. So these data set I have uploaded in the Weka, and now I'm using this data set. So here I'm using the data set as the training data set, and I have chosen my suitable parameters for building the J48 classifier, and then I can click start, and then it has built the first J48 tree. So this is a J48 decision tree. You can visualize this tree by visualize tree option, and you can see that the tree, how the tree actually looks like here. What are the conditions on the training data set? So this information has been obtained on the training data set. This shows the relation between various variables and the class prediction. So basically it says if class value is less than 127, mass value is greater than 26, then your 26.4, then chance of being tested negative is high. There are 132 cases following this path. Only 3 are tested positive. That means 129 are tested negative. High chance. So the model is built. Now, after the model is built, and you can also see the prediction accuracy is correctly classification is 78% for this model. And you can actually improve the classification accuracy in various ways, but that's not the focus of this video. So I can, and I have other videos that you can watch. Now I need to load this model. So I can load this model. This model that you are seeing here can be saved so that it can be used for future prediction, for the testing data set, for the records for which class values are not known. So how do I do that? I save that model. Save that model, and then you can browse to the folder where you want to save the model. So I am browsing to that folder, future prediction, and then I'm saving the model. Let me give the name as it is J48 model. It's a model object file. I'm saving it as, and the model is saved there. So now if I go to that folder, now in that folder, I previously had these 3 ARF files, diabetes, and from which I created testing and training diabetes file. Now I have this model as well. So once I have saved the model, then I can also load that model. So if I go to this result pane in this Weka classify. So for example, in future, now you have got access to some records for which you do not know the class value. You have got these records there. So this is what we call testing data set. Testing data set is in the records that are coming in future or sometime when those records have all other non-class attribute values, but they do not have the class values. So can we predict the class value? So when this has arrived, then you can actually open the model that you have saved before. So they call it load model. How do you do it? You come to Weka Explorer again, go to the classify tab, and then you right click here, and then you can load the model. And then it has taken me to that folder, and I can see diabetes J48 model that I just saved. So I will open that model. So the model has arrived, opened. I can see the model as usual, as you have seen before. I can see the model. Now I can actually use this model to predict the records here, predict these records. How do I do that? First, I need to upload this data set as a supplied test data set. So I can choose that set and open file. Now I need to go there and see that testing.arff file. So this is the file that I'm opening, and it has the same class value here, and I'm closing it. So that file has been taken into account as a supplied test data. And then if I go to this more option, I need to have this output prediction needs to be as a plain text output if I want to output it as a plain text. So let me choose that and click OK. And then I can right click on this model that I have just uploaded, just loaded the same model that I created before, and go to re-evaluate model on current test set. I can click on it. And once I have clicked it, then there will be a new section called prediction on user test. And here I can see the test results on the 5 records, on the 5 instances. So let me show you those original files. Here, this is the original testing data set. We have 1, 2, 3, 4, 5 records for which class values are unknown. And here I have the training data set that also does not have those 5 records. These 5 records are not available in training data set. But because this is a demonstration purpose, we have the original data set, right? So where we have taken these 5 data set from. So now for this demonstration, we have an advantage that we know the ground truth results. We know the actual class values. And now we can actually see whether our Weka prediction is matching with the actual values or not. So the first instance is predicted, tested positive, and I can see the first instance is tested positive. The second one is tested negative. The second one is actually tested negative. The third one is tested negative, and the third one here is tested positive. So that's an incorrect prediction. First two of them were correct. Then the fourth one is tested negative. The fourth one is tested negative, and the fifth one is tested positive. Fifth one is tested positive. So out of these 5 predictions, it made 1 incorrect prediction, but remaining 4 were correct prediction. So this is how you can predict unseen record, because remember, we supplied this data set. We did not supply this data set. So your model did not know the actual class values. It did not know that. All it knew is these results, other values, and the class values were missing, and then it made this prediction. And it made it quite a good prediction, in the sense that about 80% accuracy, 40 and 40, 80% accuracy, so just 1 incorrect prediction. And of course, as I said at the beginning of this presentation of this video, that you can improve your accuracies many ways. For example, here, when we built this data set, we actually built this model. We actually chose 50 records as a minimum. So maybe that was a bit too much, too much of generalization. I could make it a little bit overfitted, little bit less generalized, by choosing 20 records is enough for a class value. And then I could build a classifier based on that. And that classifier might have a little bit of better accuracy on the testing data set as well. On top of that, I could choose some other more advanced techniques, like instead of just 1 single tree, I could possibly use algorithms like SIS4, where I could have the same number of minimum number of records, but I could build more number of trees, not just 1 tree, say 3 or 5 trees, and I could possibly build this model. Sorry, on the training data set, I could build this model, and I could possibly get better accuracy there. So now we have got some trees here, 1, 2, 3 trees, 5 trees, and these 5 trees can be used the same way for the prediction purpose. Hope this has demonstrated how you can use a model that you have already built. Now you can also play with this overfitting, underfitting things, So when you build more number of, less number of records there, maybe 10 records per leaf, you are kind of trying to make a more overfitted, less generalized tree or forest ensemble of tree. And then you may see how that impacts your accuracy on the training data set and accuracy on the testing data set. Generally speaking, overfitted trees could be better in terms of its classification accuracy on the training data set, because it knows the training data set more closely. And in knowing that, it actually considers some patterns which are not general patterns, which are specific to this training data set, which might have just happened accidentally or somehow. But by knowing them, it can actually classify, this overfitted model can classify a training data set very well. But when it tries to apply that overfitted knowledge on a testing data set for in future data set, then it might make more mistakes. So that's one interesting thing, because the pattern that it is using to classify or to predict a class value is not a general pattern. It's just happened somehow accidentally for the training data set. So you can play with those kind of things, but I think this video has shown you how to build a model and then how to save the model and how to use the model for the prediction purpose. Thank you very much. Thanks for watching.